the test cases. What kind of test cases do we write? And one of the calls that we had earlier today, this is something that we discussed in detail. There are two types of test cases. One is a test case that you will write for a single agent, like the golden path test case. Hey, if I give this input, I would want to get this output, say 100 times. The second one is edge case scenario. If I give an input which is kind of trying to around the edge cases, not the core of it, but around the edge cases, I want still to see how the agents perform. The third one is negative tests, where you kind of try to do a prompt injection or try to trick the system. How does the agent respond to it? And the fourth one is tool invocation, right? Some of your agents might have to call certain tools to do this job. So you would want to see the rigorous nature of the tool calling feature. Okay, does it call tool every single time? So these are the test cases that you can write for individual agents. The other scenario is for workflows. Think of workflows so workflow like this, where you have multiple agents that are kind of connected together in a workflow, and all these are logical workflows. So they have conditional logics here. It's also DAG orchestration, which we discussed yesterday. So first thing to test in a workflow like this is, first of all, are these agents executing the event logs, right? So end-to-end flow testing, do they all execute in the entire flow? The second one is delegation and handoff. So when you have an agent, another example would be the managerial orchestration that we saw yesterday. Like I have a research paper builder as an agent, and it has four worker agents: literature researcher, draft writer, etc. Then when I give a task to it, okay, write a research paper on LLM hallucinations. So here you would want to test and see whether the agent is able to hand off from the main agent, the master agent, research paper agent, to a literature researcher, to a draft writer, and so on. So that is the other test case that obviously you would look at from a workflow point of view or orchestration point of view. So here the main agent is still thinking, and it has a thought, and it understands that it needs to write a paper on LLM hallucinations, and it's going to call the next agent to pass on the task. Let's see if it's able to call. So yeah, it's able to call the literature researcher. So the handoff happened. So that is the other test that you look at from a workflow point of view. Then comes routing and logic branch testing. Again, as you saw in the previous example, we had, we had a scenario where there are routers coming into picture. This is another example where you have routers coming into picture, and you can test whether it is routing properly through the workflow. And the fourth one is failure and concurrency, which is more of a load testing that you would do at a large scale. Okay, if I run 100 jobs parallelly, does it still work? Or the memory maintained at an individual flow level instead of getting mixed up with other flows as well, or other execution. So these are the test cases that you could do from an agent and workflow point of view. And at Lyzr, we are working on building this and launching as a standalone module as well. And that is where the complexity increases. So this is a research paper that we are writing. You could see this here. This is how do we handle a multi-agent reinforcement learning from feedback scenario. And I'll show you the architecture to just understand the complexity involved so that you'd appreciate why this test cases is not kind of a straightforward thing that we can think of. So look at this scenario where you have a multi-agent system. It is sequential orchestration, but within each, there are two agents which also has managerial orchestration. And it is not just managerial, it is hierarchical in this scenario. And each agent can have their own guardrails, their own knowledge base, their own tools. And imagine this multi-agent system produces an output. It goes to a human, it also goes to a system. There is a human feedback, there is a system feedback, and both the feedback goes to a feedback processing agent. Now, the feedback processing agent understands the feedback coming in, but it also has to understand how to break this feedback down and update individual agents. This is where the intelligence of this agent comes in handy. It needs to know the metadata of all the agents. It needs to know what is the entity relationship between these agents, how are they orchestrated, what is the overall goal, and then the feedback processing agent has to break it down and share feedback to individual agents. And once it updates to the newer version, it goes through the test cases. The test cases, like you saw here, could be various test cases that might be written, automated test cases that the agents can write, and also manual test cases that the humans would have written. And if the test cases pass through, well and good. The feedback goes to the feedback processing agent, and the newer version becomes the standard version now. But if the test cases fail, now a conflict resolution agent comes into picture because it has to now investigate why it failed. It could be because the updates were wrong. So the feedback processing agent will have to now roll back to the previous version and look at whether it wrote the right instructions to the right agents and redo the whole thing. And imagine this loop happening tens and hundreds of times until the whole multi-agent system is updated. So the complexity when you move from a single agent test case to a multi-agent test case, I mean, just grows by 100x, literally. And your feedback processing agent should also have a central memory for the multi-agent system so that it has the context. And because whenever a new agent enters into the system, the new agent onboarding itself is a process altogether, which again goes through the same loop of going through the test cases. So the test cases is actually a super important aspect when it comes to productionization, especially continuous updates that you will have to do to the agents. It is very different from what we do with, say, for example, Lovable, which is just a React front end and the logic is written at a code level. But when you think about autonomous agents where you're expecting them to work like a human, it is a very different ballgame altogether. Now, when you look at, okay, what happens within this, so here is what happened behind the scenes at a feedback processing agent and conflict resolution agent. So when the feedback processing agent sends the instructions to the multi-agent system, the agent output goes through the established test cases, which the test case agents could write, and also the human review. And if they fail, the conflict resolution agent now kicks in. It looks into agent metadata and rewrites instructions and sends the updated instructions to the feedback agent. So this is how it happens at a FPA and CRA level. But we just wanted to show you how we are thinking and how the market is evolving when it comes to test cases. This is probably a 3 to 4 month problem down the lane, but this is something that we're already seeing in the production scenarios. So test cases super important when it comes to single agents, not a big deal, and we are building and launching that module shortly. But when it comes to multi-agent system, it's a different ballgame altogether.